is the population of the U.S. from, I forget where I got this back from. I think it's hang on. I pulled this from the Census Bureau's website. 1900. In 1900 in the U.S., there were 76.1 million people in the U.S.-ish. Sorry, it's kind of small. Kirsten, my apologies. I'll break them off to you. 1901, there were 77.6 million. 1902, 79.1, 79.2. 1903, 80.6. One thing the Census Bureau is good for is getting us data like this. And you can kind of trace it down and you can say, okay, let's plan for things like Social Security based on how many people are in the country, and then also demographically where their age groups are, which is what I would like to look at too. I haven't delved far enough into Social Security to look at that. What are you looking at now? I know it's kind of hard to see because it's kind of small.
In 1918.
Good. Hold that thought. Yeah. Which negative? Over here?
No, and the first difference.
This right here?
Yeah.
Good. Check this out. What Dia's doing is she's looking at, what I did here in this spreadsheet is the same thing I just did on the board, which was take successive years and subtract and see what the difference is. So this means between 1900 and 1901, the population of the U.S. went up by about 1.5 million people. Between 1901 and 1902, it went up by about 1.6 million people. 02 and 03, about 1.5 million people. 03, 04, about 1.5. 1.6 and a half, 1.7, 1.6, 1.5, 1.7, 1.8, 1.9, 1.5, 1.5. And then down here, it actually dropped. World War I. It actually dropped. Now, I don't know if we can, I don't know how many deaths we had, and it was all guys in World War I.
The result of the lack of
Did it, you think it would have turned out that far?
The war ended in 1992.
Yeah. I mean, that's the most logical reason I have. And I always ask the question, can we attribute that drop where it's growing by 1 million roughly every year and then it drops by 60,000? Essentially, we're losing about 1 million people due to that.
But there'll be another drop in 1905 because of Spanish flu.
But the thing is, there might be a drop there, but it's so incrementally small. These aren't always going up at the same rate. Like right there, 1905 you said? How about right here? It dropped right here. It was growing by 1.6, now it's growing by 1.5. I mean, you lost 100,000 people right there. That could have been that, right? Hassani? What Hassani and Andrew are doing is they're trying to find out logic for these little inconvenient humps. Things like World War I, the Spanish flu, yes, indeed. World War II, let's keep going for World War II. The Civil War, I don't have data for that, unfortunately. I didn't go back far enough. It'd be interesting, that would be telling. That would be amazingly telling.
Americans on both sides.
Americans on both sides, exactly. So let's go down a little bit further. World War II would have been down in here, yes?
We got involved.
Right about here, 1941?
1 to 44.
44, here we go, right here. So I would imagine if you saw, look, there's a little dip right there, yeah?
Yeah, but you come back and you get the baby boom.
But look at that. Now, there's something else to recognize. At some point in this census sheet, they started counting people they weren't counting before. And I believe it was Alaska and Hawaii. And I think it was right, notice how it went from 1.4 to 2.7? All of a sudden, we're getting double the amount of new people every year? No. I think what they did right then was they kept, when was Hawaii annexed, or when was Alaska annexed? Was it right around this time? Somewhere in this time-ish? What am I doing? Let's go find out. Why am I asking? Was it around this time? Google, the death of I wonder. Alaska statehood date. I didn't even spell it right. Let's see if Google's smart. Statehood date. List of U.S. states by date of statehood. I'm going to trust Wikipedia. Is that okay with you guys?
Yeah.
I thought it was the 50s. I could be wrong about this.
I think it's the...
Yeah, I thought so too. It doesn't matter because we're not going to find out because the network's so slow right now. Oh, it's frozen. Good. Oh, there we go. Yep, it is the 50s. Look, you can tell right there by the dark blue colors. So, this, I fail to see that's big. It could be, there's a jump of 3 million, 2.6, 2.6. I wonder if they started pre-counting Alaska and Hawaii, knowing that was coming down the pike, putting them in the census because they were essentially American territories at that point.
When they start counting for the census.
That's what I have to go back and look at.
Puerto Rico.
Well, the baby boom, yes, I'm totally with you there, Linda. I'm totally with that. If you think about that from a mathematical point of view, imagine if all of a sudden every family in America that was going to have 1 kid decided to have 2. Right? Think about the impact that would have on the population of America. Okay? Say that again?
For the state, even,
How?
you need 3 children for population growth.
Oh, careful, careful, careful. No. I'm talking about year to year. So you have, say, a man and a wife, right? And they're planning on having 1 child, so that's 3. They instead have 4. So right now, those 3 people, and I'm making this overly simplistic. Let's say that every triple of people in America can be classified into a family that's planning on having children. I'm being overly simplistic, I apologize for that, but it helps with the mathematics. So if you take, say, 3 million people, that's 1 million dads, 1 million moms, 1 million kids. That becomes 4 million people the next year, yeah? That's an increase of 1 million people just by a baby boom. And that could explain quite a bit of what's going on over here. Now, I know I'm being overly simplistic. But there's also more than 3 million people in America at these times. It's 129 million. Yeah, Benji?
I get what he means by three children, because that's, you know,
A +1 after the parents die.
Exactly.
Yeah, it's a net, but he's talking about generations. I'm talking about the next year.
All right.
No, did you guys catch what Hassani's saying, which is important? This is why, when Jen and I were hippies, it took us years to decide to have a child. And the only reason we were okay with it was we said, okay, we're hippies. The world's overpopulated, but we're hippies. If we have 1, that's +1. But when the 2 of us die, hopefully before max, we leave a net -1. Because 3 became 1. So now from 3, max is the only one left. There were 2, now there's 1. Does that kind of make sense? That's what Hassani's talking about. Generationally, yes. I'm talking about year-to-year growth. A baby boom isn't felt for decades later, usually, as far as economically. Thank you, Hassani. Please, Andrew.
What is your column E? What is that?
Oh, I'll get back to that. I promise I'll get back to that. Okay? But all I want you to do is to realize we're down here. Last I have is the 2011, 300 million Americans-ish. And I haven't updated, unfortunately. Here's all the data right here. So, Andrew asked, what are these columns? Well, you guys know what the first column is, yes? I mean, Linda picked that up, or excuse me, Di picked it up immediately. She's like, wait, why is that negative? That was a drop from 1912 to 1913. The second column over here is the same thing we did with the quadratics. I was looking at the second set of differences. So remember how in the quadratic we went out and we found the odd numbers? And we said, oh, what does that mean? And we went out 1 further. We said, oh, look, this is kind of slick. Out here, we can go 1 more and it's constant. Well, the problem is, look at these numbers. Are they constant? No. So it doesn't. Go ahead, Andrew.
I was going to say that. I think that's more reflective of the stuff we were talking about as far as more.
What you're looking at there is acceleration. The acceleration of the population growth rather than the velocity. Does that make sense? I don't know if that makes sense. What you're looking at in that second column is how fast the change in population is changing. Hopefully that makes sense. Hopefully that does. So that's the idea. So basically the acceleration is not constant, which means it's not quadratic. But if you look at the graph of the data, which I got over here, take a look at it. It kind of does this, yeah? It's got a little bit of a belly right here, around 1940. But that could be easily explained by the fact that right around that time when those numbers spiked due to census data collection methods. But if you look at the overriding shape, it kind of looks curvy. So maybe we should try an exponential thing, yeah? So rather than doing it with the TI, because I really don't want you guys putting all these data points in your TI, and rather than doing it with Excel, because Excel's kind of dumb in that it doesn't let you pick the right base, it uses this kind of a base called base E, which I don't want to really get into. What I'm going to do over here in this column, can you guys see this column over here? It says percent differences. What I'm going to do is, I'm going to look at each year divided by the year in front of it. Not subtracted, which would have been the first differences, but the percent differences. Okay? And I'm going to drag that formula down. I'm going to drag that formula down all the way.
Wow.
Uh-huh. Now, isn't that slick? What does that tell us? Now, first of all, why did you say wow?
Because it's
Which is, just so you know, the same thing I said when I first found this data. Actually, there were a few expletives in there, too. Yes, Benji.
We are gaining on 2%.
Or 1%, depending on where we are, yes?
Yeah, 2 or 1% every year.
Every year. So what I'd like to do, with your permission, I'm going to average those percentages to see what it averages out to, because there's a bunch of 1s and a bunch of 2s. I'm going to average it to make it a... we'll just do that down here. We'll just do equals average. Now, this is a little bit unfair to do this, because I'm averaging. I should be doing a weighted average, but it's okay. It's good for rough and ready. Uh-huh. averages to 1%, which means on average, what is happening to the United States year to year? We're picking up about 1% more each year. I'm curious to see if this continued through 2012. I don't think we have census data for 2013 yet because we're still in it. Let's see if I can grab some census data for 2012. Let's see how good my Googling is. Census data, U.S. population 2012. Actually, let me just do this. Google might tell me this directly. Nearly 313 million people. Hang on. Hang on now, hang on. We'll enter 2012, the population of 312.8 according to the U.S. Census Bureau's end of 2000. Okay, let's use, here's the number they're using. That's what the Census Bureau, I'm going to trust U.S. News is actually giving me the correct number pulled from the census data. Yes, okay. I'm going to copy that number over to here. 2012. Put him in there. Take the commas out because why is it formatted?
Yes,
Oh God, what am I doing? Oh sweet
Go back
Jesus.
up to take the decimal down.
General. Okay, there we go. Let's just see. Now remember this is 1.0. I'm going to put this over here. There we go. Let's just see what happens if I take 2012's and divide it by 2011's. Oh, look at that.
Because you didn't put zeros in it.
Hang on.
You didn't round it.
Because I didn't put zeros.
The others are rounded to 0, 0, 0 at the end.
Oh, so you're saying that precision? Let's see if that matters. This would be a 1, right? This would be a 1 and 3 zeros. I'm not sure that would make a difference. They might die.
No.
Still 1.004. So we're off by 0.6% in that growth. But that's still damn close to 1% growth. It still grew from 2012 to 2012. It's still growing. And I'm not saying it had to be at 1%. It had to be at a 1% what? What has the United States been doing over the past 112 years? It's been growing at an annual average rate of 1%. You remember there were some years in there where it was above 2, it was above 1%, it was 2%, 1.5%. It's just in 2011, 2012, it still grew. It picked up about 1 million people, about 1.1 million people. 1.1 million people just isn't quite 1% of what 311 million is back here. It's more like 0.4%. More on this model. We'll play with this model next time. We'll see if we can predict 2013. Then I can email you guys in a year and find out how close we were. Cool? This is exponential growth. Yes, we'll fit the curve to the date as well next time. Hey, for next time, I don't see you until Monday. I should have done this at the beginning of class today. I'm sorry I didn't do it. Bring whatever questions you have on quadratic modeling, because that's going to be on your in-class on Wednesday of next week. Let's make sure you guys get any questions at all answered for that. Cool? Yeah. Okay, good. We'll catch you. We'll do more exponential stuff on Monday, and then we'll get into